Hey there guys, this is your fall final exam review, day 2 review. So at this point, you should have already have taken your practice fall final exam. So you should more or less know what you need help with and what you already understand. So use this resource to help you to study what you need to, or you can watch the entire thing to review all topics that will be covered in your fall final exam. The first major topic we are going to be covering is it a function? So how to tell if something is a function. Now, you'll see the wording look like number 1. Does the following mapping show y as a function of x? All it's asking is this a function? And remember, for it to be a function, there has to be no repeating x values. So we look at the leftmost mapping, or the leftmost circle. That will always be your x values, and the rightmost will always be your y values. Now to tell if there's repeating, you'll have repeating when there's double arrows. So A goes to B, so there's no repeating. A only goes to B. B goes to C, okay, no repeats. And D goes to B, no repeats. Now you might say, well, what about C? C doesn't go to anything. Doesn't matter. As long as we do not have any repeating input values or x values, it is still considered a function. So yes, it is a function because there is no repeating x values. Now you might say, well, what about that b value? They share the b value. That's also okay. That just means that the y repeats. You'll have an AB and a DB. We don't care about repeating y, so it doesn't matter if they share here. As long as every single thing on the left side has its own arrow, it is still considered a function. Now for number 2, it's still the same idea, so you see the wording is still similar. Does the following graph show y is a function of x? Still asking is it a function, but this time it is asking for you to be able to do it from a graph. So remember, when we have a graph, we have this very useful tool called the vertical line test. A vertical line test will go straight up and down, and it tells you, okay, if I draw a vertical line through my graph or through the shape they give me, and it only hits one time, it is a function. However, if it hits more than one time, it is not a function. And it still follows the same idea that you can't have repeating x's. So if I write this point as a coordinate point, you'll see you'll have -2, 2. And this coordinate point down here is still -2, but it's -4. So -2, -4. Oops. Hence, you'll see that you have repeating x values, -2 and -2. So this is not a function because it does not pass the VLT vertical line test. Number 3 and 4 are both similar. They're both determining if something is or is not a function based on a table of values. So looking at these table of values, it still says, okay, does the following show y is a function of x? Well, we look at our x column because we want to look for repeating x's. We see 0, 3, -3, and 2. 3 and -3 are separate numbers. One's a +3 and one's a -3. So these do not count as repeating. So this one is a function because there's no repeating x values. Now you might have noticed that there are repeating y values. You'll notice there's a 4 here and a 4 here. But we don't care about repeating y values. We only care about repeating x values. So since there are no repeating x values, it is a function. For number 4, still the same idea. So we'll still see if this is a function by looking at our x column to see if we see any repeating x values. And we do have repeating x values. You'll notice that the zeros repeat. So in this case, this one is not a function. You also have repeating y values, but that doesn't matter. The only thing that made it not a function was those repeating x's. So that covers the first general topic of your final exam. So now we will go into PEMDAS. PEMDAS, remember, stands for parentheses, exponents, multiply and divide, add and subtract. The multiply and divide and add and subtract kind of go together in their own categories. So it just goes from left to right. You'll see what I mean. So for number 5, PEMDAS tells us to start with P parentheses. So we're going to start inside the parentheses. So 3 plus 2 is 5. And I'll bring everything down. I'm done with my parentheses. Exponents, there's no exponents. So next I'm going to go to multiplying or dividing. Usually you go left to right. So starting on the left, I do see a multiply. I know when a number touches a parentheses, it means they're being multiplied. So 6 times 5 is 30. And I bring everything else down. Now be careful. Your next step is not to do 30 plus 20. That would be incorrect. Instead, what you're going to do, multiply and divide. Make sure that you've done all the multiplying and all the dividing. I have a dividing here. I have to do that first. That's what PEMDAS tells us. It's order of operations. So I'm going to do the 20 divided by 10, which is 2. And then, finally, 30 plus 2, which is 32. Notice if you go this order, if you do the 30 plus 20 first, you'll get a 50 divided by 10, which is 5, which is a much different answer than the 32 we got. So the order of operations does matter. So be careful about that. You can also plug it into your calculator. Your calculator will do it for you. It does order of operations as long as you're being very careful with your parentheses. So the next one is 3 times the quantity of 6 divided by 2 plus 4. We'll still start with parentheses, but there's multiple numbers in our parentheses. So we continue on in PEMDAS. It tells us, okay, well, multiply and divide still go first. So I'm going to do the 6 divided by 2 before I start the adding. 6 divided by 2 is 3, and I can bring everything else down. I haven't used the 4 yet, or the 3 on the outside. Now I still have 2 numbers in my parentheses, so I'm still going to do that first. So even though multiplying should go before adding and subtracting, since I still have something to do in the parentheses, I will start there. Then you have 3 times 7, which is 21. Similar to what I said last time, you can just use your calculator and it will give you the exact same answer. Your calculator will do order of operations for you. Just make sure you're typing it exactly as shown here. Solving equations is the last section we'll go over for part 1 of the video, because it all kind of goes together. So what is the solution that makes this equation true? So if I look at this, I know that for solving equations, it's kind of reverse PEMDAS, because you want to do the opposite. You want to get n by itself. So we want to get rid of this minus 7. Well, to get rid of a minus 7, I'm going to add 7. And what I do to one side, I must do to the other. So cancel out. You get n equals 16 plus 7, which is 23. Which you can rewrite as n equals 23. But 23 equals m is the exact same thing. And you're done. Number 8, same idea. So I'm going to draw my line in the middle to kind of separate my left side of my equation and my right side of my equation. Notice on this case, there's 3 numbers on my left side. So you might say, okay, well, do I get rid of the 1 first? Do I get rid of the negative 5 first? This is a case of combining like terms. Since I see a 1 and a negative 5 on the same side, I can combine them. So, negative 5 plus 1 is negative 4. Plus x equals negative 4. Bring everything else down. So we still want to get x by itself, so now we have to get rid of that negative 4. So I'm going to add 4, and what I do to one side, I do to the other. Negative 4 plus 4 is 0, which is okay. Sometimes you get 0. It doesn't mean you did anything wrong. So my answer is 0. Number 9, you see a lot of decimals. Do not let that intimidate you. Still the same idea. We're still going to draw our line. And on the left side of the equation, we'll say, hey, I see a negative 5.2, but I also see another number with an x. the negative 6.2. Since both of these numbers have not only a variable, but the same variable, they can be combined. So you'll do negative 5.2 minus 6.2, which will give you negative 11.4x. Now let's see if there's any other like terms. Well, you'll notice you have a 1.6 that does not have an x, but you also have a 6.3 that also does not have an x. These are considered constant numbers that don't change, numbers without variables. Those can be combined. So if I add the 1.6 and the 6.3, these will be positive, and you will get 7.9. And you bring everything else down. So the negative 14.9. So your first step was just to combine like terms. Once you've combined like terms, well, now we can solve like normal. You want to get the negative 11.4x by itself, so we have to get rid of this plus 7.9. So we're going to subtract 7.9 from both sides. I should have written smaller. Whoops. You can use your calculator for this. You don't have to do it in your head, so if you think it's difficult to do in your head, use a calculator. Oops, wrong color. And you get negative 22.8. Your last step is to get x by itself. It's being multiplied by the negative 11.4. So you're going to divide by the 11.4. Which will give you 2. You don't have to have this memorized or able to do it in your head. Feel free to use a calculator. Last one, for part 1. We are going to combine like terms if we can. And in this case, we notice that we can because we see the constant 1, the number without a variable, but we see another number without a variable, the 5. We can combine to a positive 6. Then I will bring everything else down. You want to get your variable by itself, so in this case the m. So I'll subtract 6 from both sides. And you get m equals negative 3. So this is about as difficult that you will see on your fall final exam. Number 9, you won't see anything with decimals or all equal numbers, like numbers 7, 8, and 10. But 9 was good practice of just the idea of combining like terms. So make sure you're able to do that so that you are able to do it on your final exam. So that ends part 1. Part 2 will cover the rest of your review.